Today, on Science Talks, we will be demonstrating a chemiluminescence reaction using luminol.
Let's get into the lab to start the procedure. The equipment you will need are two 500 milliliter beakers, two 140 milliliter beakers, one graduated cylinder, two watch glasses, one stir stick, and two sputulas. The chemicals we will be using are bleach, luminol, and sodium hydroxide.
When dealing with chemicals, it is very important to take the necessary safety precautions. For every chemical used in today's procedure, it is very important to avoid contact with your skin and to avoid contact with your eyes.
For sodium hydroxide, it is important to also store it in a dry area.
And with luminol, it is very important to keep away from open flame or heat. Before you begin this procedure, you need to make sure you are wearing the proper safety equipment. Your hair must be tied up and you need to be wearing closed-toe shoes. You must wear safety goggles at all times, followed with an apron and gloves. To begin this chemiluminescence reaction, we need to dissolve 0.05 grams of luminol in 100 milliliters of 1 molar sodium hydroxide.
You need to add the sodium hydroxide to 100 milliliters of water to make this solution. Add the two together and mix with a stir stick. You want this to be perfectly dissolved.
Now that the sodium hydroxide is done dissolving, you have to add the 0.05 grams of luminol to the solution.
In a separate beaker, you need to get 91 milliliters of deionized water.
Look at the sunlight.
You need to add 9 milliliters of bleach into a graduated cylinder and then add it to the solution.
The next step is to chill the solutions. You'll need to get a large beaker and put some ice water in it. Next, fill them about half full with cold water.
Put solution A and solution B into their own ice bath. Once the solutions are chilled, pull them out and dim the lights. Pour the two solutions together.
Beakers with the ice water can just be poured down the sink. However, the solution you created is go in caustic ice.
When you add solution A and solution B together, they become unstable and have a high amount of energy.
The solution needs to release this energy, and it does this in the form of light. When the light is gone, this means the solution has become stable.
Stable solution is a yellowy-green color, and the blue light is no longer emitted.
This is the chemical equation for this reaction.
This is an oxidization reaction where luminol loses nitrogen and hydrogen atoms and gains oxygen atoms from the hydroxide.
This produces a compound known as 3-aminophthalate. This compound is left in an energized or excited state where the electrons are in high orbitals.
The electrons will fall to the ground state and release energy in the form of colored light.
All of this occurs so that each atom can acquire the electron configuration of the noble gas. Every atom wants to become stable, and to do this they need to have a full valence shell. This is why the two solutions react with one another and release the light so that they can become stable